Welcome to Lecture 13 of Computer Programming Fundamentals. L13, Structured Programming in Java. The development of reliable computer programs hinges on the adherence to structured programming best practices. Structured programming best practices independent of any specific computer programming language. As such, it is not the specific computer programming language deployed that ensures the development of reliable computer program code, but rather the adherence to these structured programming best practices. Therefore, once knowledge of structured programming best practices is achieved, given the C computer programming language, that knowledge can be applied universally to all computer programming languages, including the Java computer programming language. As such, Lecture 13 demonstrates the successful migration of structured programming best practices from the C computer programming language to the Java computer programming language. In fact, the same computer program models used in Lecture 7, structured programming in C, these same computer program models will be converted to the Java computer program language. This proves the sustainability of the structured programming best practices originally established with the C computer programming language. Lecture 13 also, more importantly, proves the transition from the computer programming language procedure-oriented paradigm to the computer programming language object-oriented paradigm. Getting back to the adherence to structured programming best practices requires that all computer programming logic routines are confined to three principal families of control structures, namely sequence, repetition, and decision. Lecture 13 will demonstrate these families of control structures in some detail, given the use of the same computer program code models developed for Lecture 6, Structured Programming in C, but adapted to the Java computer programming language. This shows the dramatic influence the C computer programming language has had on today's dominant computer programming languages, namely those based on the computer programming language object-oriented paradigm. The three families of control structures which provide the underpinnings for structured programming best practices can further be subdivided. The sequence family contains only one control structure, whereas the repetition and the decision families can be further subdivided. The repetition family includes three individual control structures, namely the for, do-while, and while individual control structures. The decision family includes two individual control structures, namely the if and the switch individual control structures. Each of these individual control structures is independent of any specific computer programming language. Thus, they can be applied universally to all computer programming languages, even across all computer programming language paradigms. So let's demonstrate them using the Java computer programming language, the computer programming language that gave birth to today's dominant computer programming languages, those based on the computer programming language object-oriented paradigm, where it is still essential to produce reliable computer program code. Computer Program Code Model L13A demonstrates the sequence control structure. The sequence control structure is typical of the main method definition computer program code, where computer program instructions are executed in sequence. Computer Program Model L13A.Java is the Java computer program that duplicates the C computer program L7A.C discussed in Lecture 7. Note the output displayed in the command processor is identical to that of the C computer program L7A.C. Okay, let's take a closer look at the Java computer program L13A.Java. Here note the location of the computer program declaration instructions. Declaration of data variables local in scope and age to the main method definition, namely int num semicolon, string num1 semicolon, string last name semicolon. These computer program instructions must be placed in the sequence before the show input dialog method calls that use these data variables as arguments. Note the use of the JOptionPane class that contains the show input dialog method. The single show input dialog method replaces the tortuous printf and scanf function call combinations for user data entry. This is a much improved approach provided by the Java computer programming language for entering user data. The downside is that for numeric data, a parse int method call is required to convert string data to numeric data, because the show input dialog method inputs all data as a string data type. Note the declaration computer program instruction string num1 semicolon, where a data variable num1 is assigned the result of the show input dialog method call, because num1 is assigned as a string as a result of the show input dialog method call. It must be converted to an integer given the parse int method call. I trust L13A.java not only demonstrates the sequence control structure, but more importantly demonstrates the improvements made by the Java computer programming language, while still sustaining the structured programming control structures originated by the C computer programming language. Computer Program Code Model L13B.java demonstrates the for loop control structure. The for loop is a member of the repetition family of control structures. The for loop is used when the number of repetitions is predetermined. Predetermined are fixed before the execution of the underlying computer program code. Okay, let's take a look at the structure of the for loop control structure, namely for left paren, mynum equal 1 semicolon, mynum less equal 6 semicolon, mynum plus plus right paren, left brace, square equal mynum asterisk mynum semicolon, system.out.println, left paren, double quote, square of mynum, double quote, plus double quote, equal double quote, plus square, right paren, semicolon, right brace. Note this is the exact same code that was used for the C computer program model L7B.C, with the exception that the println method call replaces the printf function call, which demonstrates that the syntax of the C computer programming language has been carried forward in the Java computer programming language. First, the for loop header part. For left paren, mynum equal 1 semicolon, mynum less equal 6 semicolon, mynum plus plus right paren. This reminds me of the method definition header that we discussed in Lecture 12, Java Basics. Note the for loop header sets the stage for the repetition code that follows, that sandwich between the braces. Within the parentheses of the for loop header, we see 3 computer program assignment instructions, namely mynum equal 1 semicolon, mynum less equal 6 semicolon, mynum plus plus. Of these 3, the first, mynum equal 1, assigns or initializes the data variable mynum with a value of 1 before the for loop begins. In other words, mynum is set to 1 before any of the repetitive computer program instructions execute. Those computer program instructions between the left and right braces. The second of the 3 instructions included within the for loop header, namely mynum less equal 6, sets the limit for the fixed or predetermined number of repetitions. In this case, 6 repetitions will take place because mynum starts off as 1 and terminates when mynum is not less than or equal to 6, which leads us to the third of the 3 computer program instructions included within the for loop control structure header, namely mynum plus plus. The plus plus operator after the data variable mynum provides an example of a post-unary increment operator, which increments the data variable mynum by 1 after one execution of the repetitive computer program instructions. Thus, in this case, after one repetition, the value of mynum will be set to 2. So before we take a look at the repetition part, let's summarize the for loop control structure header. In this case, it provides 3 functions to control the number of repetitions, sets the start value to begin the number of repetitions, sets the limit to end the number of repetitions, increments the data variable controlling each repetition. Now let's look at the repetitive computer program instruction part, namely left paren, square equal mynum asterisk mynum semicolon, system.out.println, left paren, double quote, square of mynum, double quote, plus double quote, equal, double quote, plus square, right paren, semicolon, right brace. The first computer program instruction, square equal mynum asterisk mynum semicolon, assigns the square of mynum to the data variable square. The second computer program instruction, system.out.println, left paren, double quote, square of mynum, double quote, plus double quote, equal, double quote, plus square, right paren, semicolon, is your basic println method call that displays the result of each repetition to the console. Note the next first repetition, the value of the square is 1. And with the last repetition, the value of square is 36. One last point to examine, namely computer program instruction int mynum, comma, square, semicolon. Here data variables local in scope and age to the main method definition are declared prior to their use in the for loop, which is also included in the main method definition. Take a look at the placements of braces that demarcate the main method code with the braces that demarcate the for loop repetitive computer program instructions. Note here the indentation to improve computer program readability, as well as ensuring the balance of right and left braces. In conclusion, I trust that computer program code model L13B demonstrates the advantage of the for loop control structure over the sequence control structure, particularly when the execution of predetermined repetitive logic is a crucial part of the computer program, a crucial part of the computer program that demonstrates a structured programming best practice, a structured programming best practice for supporting repetitive predetermined logic, a structured programming best practice that has successfully migrated to the Java computer programming language, where the Java computer programming language has become the forebearer for the computer programming language object-oriented paradigm. Computer Program Code Model L13C.Java demonstrates the do-while loop control structure. This computer program model is identical to Computer Program Model L7C.C, demonstrating the migration of structured programming best practices first developed for the C computer programming language to the Java computer programming language. The do-while loop is a member of the repetition family of control structures. The do-while loop is used when at least one repetition will be performed. Okay, let's take a look at the structure of the do-while loop control structure, namely do, left brace, system.out.println, left paren, double quote, this is the double quote plus I plus double quote iteration, double quote, right paren, semicolon, I equal I plus 1, right brace, while, left paren, I less equal 3, right paren, semicolon. First, the do-while loop header part, just do. While the do-while header sets the stage for the repetition code that follows, that sandwich between the braces. Thus, the keyword do starts the execution of the repetition computer program instructions, those between the braces. Nothing more, as in this case there are no computer program instructions included with the do keyword to control the number of repetitions. As such, for the do while loop control structure, at least one repetition will be performed. Next, let's take a look at what terminates the do while loop, namely the while part. While, left paren, I, less equal 3, right paren, semicolon. This is a computer program instruction that contains the while part. Note the semicolon terminating the while computer program instruction. This computer program instruction reminds me of a method call where I less equal 3 is an argument passed with the call. In this case, computer program control will be returned to the do header, while the data variable I is less than or equal to 3. So the while part sets the limit for the number of repetitions performed. Next, let's take a look at the repetition computer program instruction part, the part between the left and right braces, namely left brace system.out.println, left paren, double quote, this is the double quote, plus I, plus double quote, iteration, double quote, right paren, semicolon, I equal I plus 1, right brace. The first computer program instruction here, system.out.println, left paren, double quote, this is the double quote, plus I, plus double quote, iteration, double quote, right paren, semicolon, is your basic println method call that displays the result of each repetition to the console. Note for the first repetition the value of data variable I is 1. No surprises with the do while control structure. At least one repetition will be performed because the do while loop termination decision comes after at least one repetition. In this case, when data variable I is less than or equal to 3. Well, so far we have discussed the beginning and end part of the do while loop control structure. Take a look at the second repetitive computer program instruction, I equal I plus 1. Here the data variable I is incremented. In other words, in this case, the incrementing is performed as part of the repetitive computer program instruction part. One last point to examine, namely computer program instructions INTI semicolon I equal 1 semicolon. Here data variable I is local in scope and age to the main method definition. Data variable I is declared prior to its use in the do while loop. The declaration is also included within the main method definition. Take a look at the placement of braces that demarcate the main method code with the braces that demarcate the do while loop repetitive computer program instructions. Note here the indentation to improve computer program readability, as well as ensuring the balance of right and left braces throughout the entire computer program. In conclusion, I trust that computer program code model L13C.Java demonstrates the differences between the do while loop control structure and the for loop control structure previously discussed. Computer program code model L13D.Java demonstrates the while loop control structure. The while loop is a member of the repetition family of control structures. Okay, let's take a look at the structure of the while loop control structure, namely while left paren, minum explanation equals 0 right paren, left brace, square equal minum asterisk minum semicolon, system.out.println left paren, double quote, square of double quote plus minum plus double quote equals double quote plus square right paren semicolon, minum equals 0 semicolon, right brace. First the while loop header part, while left paren minum explanation equals 0 right paren Here the termination decision of the while loop is made. If the data variable minum is not 0, at least one repetition will be performed. One repetition of the computer program instructions included between the braces. So in the case of the while loop, the decision to perform the repetition is made at the beginning, whereas with the do while, the decision to perform the repetition computer instructions is at the end. Therefore, depending on the value of the data variable minum, there could be no repetitions. For example, if minum starts off as 0, whereas for the do while loop, there is always at least one repetition performed, because the decision point for the do while comes after the repetitive computer instructions. Whereas for the while loop control structure, the decision point computer program instruction is included as part of the while loop header, a computer program instruction using the comparison operator explanation equal or not equal, included before the execution of the repetitive computer instruction. Okay, next let's analyze the repetition computer program instructions part, namely left brace, square equal minum, asterisk minum, semicolon, system.out.println, left paren, double quote, square of, double quote, plus minum, plus double quote, equals, double quote, plus square, right paren, semicolon, minum equals 0, semicolon, right brace. Here the first repetitive computer program instruction, square equal minum, asterisk minum, semicolon, is a computer program assignment instruction that assigns the square of data variable minum to the data variable square. Next, the second computer program instruction here, system.out.println, left paren, double quote, square of double quote, plus minum, plus double quote, equals double quote, plus square, right paren, semicolon. This is your basic println method call that displays the result of data variable square to the console. The next computer program instruction, minum equals 0, semicolon, sets the data variable minum to 0, which terminates the while loop. As the return to the while loop header, namely while, left paren, minum explanation equals 0, right paren, where the condition for executing another repetition will fail, now that data variable minum is equal to 0. Thus the while loop is terminated because the decision point is before the repetitive computer program instructions. One might ask, how do we handle the first time initialization for the data variable minum? To answer this question, take a look at the computer program instructions, those instructions outside the while loop control structure, but within the main method definition, namely int minum square semicolon, minum equal 1 semicolon. The first computer program instruction, int minum comma square semicolon. Here data variables minum and square are declared as integers. These data variables are local in scope and age to the main method definition. As such, since the while loop control structure is within main, these data variables scope and age range applies to the while loop control structure. The next computer program instruction, minum equal 1 semicolon, because not minum is assigned the value of 1 initially, there will be at least one repetition of the while loop control structure. Computer program code model L13E.Java demonstrates the if-else decision control structure. The if-else is a member of the decision family of control structures. The major feature of this member of the family of decision control structures is that for the if-else decision control structure, only two choices for the decision are presented. Given these two choices presented, only one decision path can be taken. Or in other words, if the condition is met, the choice or path is taken. Else, if the condition is not met, the other choice of the two presented is taken. Okay, let's take a look at the if-else decision control structure. If left paren I equals 0, right paren, left brace, system.out.println, left paren, double quote, I is equal to 0, double quote, right paren, semicolon, right brace. Else, left brace, system.out.println, left paren, double quote, I is not equal to 0, double quote, right paren, semicolon. Here the if part, namely if left paren, I equals 0, right paren, left brace, system.out.println, left paren, double quote, I is equal to 0, double quote, right paren, semicolon, right brace, is the part where the condition is tested. That within the parentheses after the if keyword, where the equality operator equal tests the data variable I for equality to 0. If the condition test is satisfied, the computer program instructions, those between the braces following the if header, are executed. Namely, in this case, the single instruction, system.out.println, left paren, double quote, I is equal to 0, double quote, right paren, semicolon, which displays I is equal to 0 on the console. Next, let's look at the else part of the if-else decision control structure, namely else, left brace, system.out.println, left paren, double quote, I is not equal to 0, double quote, right paren, semicolon, right brace. Here the else part of the if-else decision control structure is executed if the condition expression in the if part is not satisfied. In this case, if I is not equal to 0. The code between the braces following the keyword else, namely system.out.println, left paren, double quote, I is not equal to 0, double quote, right paren, semicolon, displays I is not equal to 0 on the console. That verifies this case of the if condition failing. Okay, now that the if-else decision control structure has been discussed, let's talk about its location within the overall computer program code. Note the control structure is included within the main method definition, following the computer program declaration and assignment computer program instructions for data variable I, namely int I equals 0, semicolon. Here data variable I is declared and assigned the value of 0. Since data variable I is declared and assigned within the main method definition, the scope and age of data variable I is applicable to the if-else control structure, as the if-else control structure is also included within the main method definition hierarchy. I trust L13E.Java demonstrates the if-else decision control structure, a member of the decision family of control structures that demonstrates the structured programming best practice for decision making when there are just two choices. Computer Program Code Model L13F.Java demonstrates the switch decision control structure. The switch is a member of the decision family of control structures. The major feature of this member of the family of decision control structures is that for the switch decision control structure, multiple choices for the decision making are presented. Given these multiple choices presented, multiple decision paths are available. The specific path taken will be determined by the specific choice selected from the multiple choices presented. As such, the switch control structure is used for situations where a single choice is made from a multiple number of choice options, like a user selecting an item from a menu of multiple items. Many of today's computer programming languages refer to this control structure as the do case control structure. Okay, let's take a look at the switch decision control structure. Switch left paren, my number, right paren, left brace, case 1, colon, system.out.println, left paren, double quote, you chose number 1, double quote, right paren, semicolon, break, semicolon, case 2, colon, system.out.println, left paren, double quote, you chose number 2, double quote, right paren, semicolon, break, semicolon, case 3, colon, system.out.println, left paren, double quote, you chose number 3, double quote, right paren, semicolon, break, semicolon, default, colon, system.out.println, left paren, double quote, invalid number, double quote, white paren, semicolon, break, semicolon, right brace. The key part of the switch control structure is the header, namely switch, left paren, my number, right paren, where switch is the keyword that identifies this as a switch control structure, and where my number included between the parentheses is the data variable depending on its value that points to a specific case subheader keyword. In this case, if my number is equal to 1, the switch control structure header will transfer computer program control to the case subheader label case 1 colon. Okay, now that we know how the cases are selected, let's take a look at the case selections available part. Specifically, the computer program instructions block, the computer program instructions demarcated by the left and right braces, namely left brace, case 1 colon, system.out.println, left paren, double quote, you chose number 1, double quote, right paren, semicolon, break, semicolon, case 2 colon, system.out.println, left paren, double quote, you chose number 2, double quote, right paren, semicolon, break, semicolon, case 3 colon, system.out.println, left paren, double quote, you chose number 3, double quote, right paren, semicolon, break, colon, default, colon, system.out.println, left paren, double quote, invalid number, double quote, right paren, semicolon, break, semicolon, right brace. Here the case 1, 2, 3 and default subheaders are considered computer program labels. For example, note the colon syntax for terminating each subheader. Each label receives computer program control from the switch control structure header, based on the value of the data variable my number. The case subheaders are identified by the case keyword. Let's take a closer look at the case subheader label, namely case 1 colon. Here the case is the keyword identifying this as a case subheader. The literal data variable 1 indicates that this is the case for data variable my number equal to 1. The terminating colon indicates the statement as a computer program label. Thus, this is how the case subheader label is selected. Next, once the case subheader label is selected, the computer program instructions following the case subheader are executed. For case 1, namely, system.out.println, left paren, double quote, you chose number 1, double quote, right paren, semicolon, break, semicolon. The first computer program instruction is your typical println method call, where you chose number 1 is displayed on the console. The second computer instruction, break, forces computer program control to exit the case subheader computer program instruction block. For cases 2 and 3, the same computer program logic prevails, which brings me to the default case. Since the choices or decision paths taken are mutually exclusive and collectively exhausted, structured programming best practices for the switch control structure require a default case to process any specific choice not taken. As such, if the value of data variable my number is anything but a 1, 2, or a 3, the default case path is taken. Note the command processor where I ran the computer program for data variable my number equal to 3. Note computer program instruction int my number equal 3 semicolon, where my number is declared as an integer and assigned the value of 3. In conclusion, I trust the switch control structure demonstrates decision control. Decision control when there are multiple choices with only one choice or decision path to take.